Good evening, everyone. This is one more important session with respect to process management. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear and able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If able to recollect, what is the discussion happened in the last lecture? Will you agree? In the last lecture, we are trying to understand one system called fork system call. Okay. In the last lecture, we are trying to understand one system called fork system call. What is the use of this system call? Can I say whenever any process is calling this function, suppose this is one process is calling the fork function, can I say one duplicate process is created? Can I say to create a child process, to create a duplicate process, the fork system call is used. So here y plus 1 is called as a child process and y is called as a parent process. Can you tell me who is this? Who is a parent for this y? Can you tell me who is a parent for this y? Can I say that is the bash is the parent for this y and this is a child. Now tell me, after the fork, whatever the statements you are going to write, after the fork, whatever the statements you are going to write, can I say parent as well as the child both will execute? After the fork, whatever the statements you write, that statements is going to executed by the parent as well as the child. That statements are executed by the parent as well as the child process. So we are trying to understand yesterday when we call 2 times fork function, when we call 3 times fork function, what is the scenario? And upon success, what is the fork returns we are trying to understand? Upon success, will you agree, fork returns in a parent, it will return the child ID. In a child, it will return the 0. Upon success, in a parent, it will return the child ID. In a child, it will return a 0. Now tell me, if I write r is equals to fork, if r double equals to 0, so who will execute the body of this if? Can I say child will execute the body of the if? The else is executed by the parent. Before if and else, whatever the statements if you write, below if and else, whatever the statements if you write, can I say that is the both common code, parent as well as the child both will execute, that is a common. Will you agree? Parent as well as the child both will execute. Upon failure, I told you fork returns. Upon failure, I told you fork returns -1. So today also there are so many interesting points, so many important points about the fork system call, about the process management. So many things we need to discuss in a today's session. It's clear? If r double equals to 0, that is a common. Means this condition is checked by the parent as well as the child, because after the fork whatever you written, parent as well as the child will execute. But when the child is executed this condition in a child process, when this condition is checked, can I say in a child process this condition is true, in a parent process this condition is false. K2, got the point? P9 K2. In parent process, that if condition is false. In a child process, that if condition is true. That's why I'm using the term the body of the if. the body of the if is executed by the child, the body of the else is executed by the parent, but this condition is checked by the parent as well as the child. But the condition is executed, the condition is checked in a parent as well as in a child process. Now, today, let's understand very interesting concept here. Do you know what is a slashen in the C language? Do you know what is the meaning of slashen? Can I say slashen means the cursor goes to the next line? 0109 underscore 1 dot C. Observe, hash include header dot h, void main. Now tell me, printf hello slashen fork printf hi slashen and put the process is in a while one loop. Now my question is, how many times the hello is printed? How many times the hi is printed here? How many times hello is printed? How many times the hi is printed? Can I say hello is printed one time, hi is printed two times? One hi is printed by the parent and one hi is printed by the child. Will you agree? One hi is printed by the parent, one hi is printed by the child. Now tell me, yesterday what we observed, who is getting the CPU time slice first? In my laptop, who is getting the CPU time slice first? Can I say parent is getting the CPU time slice first? Okay. Now observe the output. Hi is printed. Hello is printed one time. Hi is printed two times. I hope there is no doubt about it. Now can you tell me why the command prompt not came? Can you tell me why the command prompt not came? Because of why the command prompt not came? Because of while one semicolon, right? Now tell me, I loaded only one A dot out, but when we type PS, will we get one A dot out or will we get two A dot outs? Now tell me, we'll get one A dot out or we'll get two A dot outs? Will you agree? From another terminal, if I see, we'll observe two A dot outs. One is a parent A dot out and another one is a child A dot out. One is a parent A dot out and another one is a child A dot out. One is a parent A dot out and another one is a child A dot out. Now, I'll press a control C. When I press a control C, will you agree both parent and child both are terminated? Will you agree? When we press a control C, both parent as well as the child both gets terminated. When we press a control C, will you agree both parent as well as the child gets terminated? Will you agree? Now observe the important point here is I'll remove the slashen here. All of you are observing the line number 4. Previously there is a slashen. Now I removed that slashen there. Now observe, when I compile this code, when I run this code, observe 2 times hello is printed. When I put a slashen, only 1 time hello came, but when I remove the slashen, will you agree 2 times the hello is printed? This output is against yesterday's discussion. Again, will you agree this output is against yesterday's discussion? Yesterday I told you, after the fork only whatever the statements are there, parent as well as the child will execute. But here this hello is also printed two times. But when I put a slash in, here, will you agree? When I put a slash in here, only one time hello is printed. Now the question arises, so what is the significance of a slash n? Normally, will you agree, slash n is one of the escape sequence? Will you agree? Slash n is one of the escape sequence. So it is used to move the cursor to the next line. But one more important thing is there about the slash n with respect to process management. I need to tell you. Try to understand. Now tell me, after compiling this program, when I load this program into the RAM for execution, can I say it becomes one process? Again, after compiling this program, when I load this program into the RAM for execution, will you agree it becomes one process? One thing I need to tell you, whenever a process is created, for this process, 3 files are automatically opened. Again, whenever a process is created, for this process, 3 files are automatically opened. Can anybody tell me what are those? One is std in, one is std out, and another one is std error. Again, whenever a process is created, whenever a program is loaded into the RAM for execution, for your program, there are 3 files are automatically opened. Now files are opened means, can I say file streams are created? I don't know, you're able to recollect it, file handling concept. What is the meaning of files opening? Can I say file streams, one buffers are created? Normally, what we will think as a C programmer, will think that printf means it will print the data on the monitor. Will you agree? What we will think normally? Printf print the data on the monitor, but printf will print the data into std out buffer. Again, normally what we'll think is printf print the data on the monitor, but actually printf will not print the data on the monitor. Printf will put the data into where? Printf will put the data into where? Into std out buffer. Std in related to the keyboard, std out related to the monitor, std error related to the monitor. I don't know you observed or not, p error function, it will print the data into std error, standard error output. If you open the man page of p error, if you read that man page of p error very carefully, you will observe one statement in that man page. Std error will display the proper error message in the standard error buffer. std error. These two are the output buffers. These two are the output buffers. These are the input buffer. Whenever you type any data from the keyboard, it will not directly come into our variable. It will come and sit into std in. Scanf will scan the data from the std in. Now once again, printf where it will put the data. Can you tell me printf where it will put the data? Printf where it will put the data into std out. Now you may get a doubt, sir, from this std out, when it will go to the monitor? Again, from this std out, when it will go to the monitor? 1, whenever you use a slash n. 2, after printf, whenever you use a scanf. 3, I don't know, you might have heard one function, fflush function. So try to understand, this hello is not directly went to the monitor screen. This hello first went to std out buffer. Now I am talking from std out buffer when it will go to the monitor screen. 1 when there is a slash n, 2 when there is a scanf after the printf, 3 whenever you use fflush, 4 when process is terminated. Normal termination. These are the four situations. These are the four conditions. These are the four situations or four conditions. So what happens is, these are the four situations or four conditions. So when the data which is present in std out, it will go to the data which is present in std out, it will go to the monitor screen. Is clear? So printf will not directly put the data into monitor screen. Printf will put the data into std out buffer. From std out buffer, the data will go to the monitor screen in these many situations, these many events, these many cases. So now you tell me, after this printf, this hello is still present in std out, it is not went to the monitor screen. Will you agree? That hello is present in the std out, it will not went to the monitor screen. Now tell me, after this printf, you are using the fork. When you use a fork, what happens? Can you tell me, when you use a fork, what happens? Can I say duplicate is created? When you use a fork system call, will you agree a duplicate is created? Now this entire thing gets duplicated. Again, this entire thing gets duplicated. So when this entire thing gets duplicated, can I say child a dot out also contains hello? This hello is also duplicated here. Y plus 1. Getting the point? That is the reason what happened is, what happens is, this hello is printed 2 times. That is not the meaning that child is executed that. As an inheritance, the child got that hello. When the child is created, at that time, parent std out is having hello. So when the child is created, that hello is also copied into the child std out. All of you are getting the point? It is not the meaning that the child is executed this. If you are getting this point, type 1 in the chat box. It is not the meaning that child is executed above the fork. No. But when the child is created, at that moment, parent std out is having hello, that is duplicated to the child. BE8 M2. Because there is no slash in here. So then what happened is, this data HELLO is not went to std out monitor screen. So when the child is created, at that time, entire parent process gets duplicated. At the time of duplication, parent std out is having hello, that is also duplicated to the child. B8 M2, getting the point? When the child is created, at the time, parent std out is having hello, that is duplicated to the child. After the fork, whatever the statements are there, will you agree, these statements should be executed by the parent as well as the child. Again, after the fork, whatever the statements you written, those statements should be executed by the parent as well as the child. All of you are getting the point? After the fork, whatever the statements you written, so now parent is executing the hi is executed, and this hello and hi both are flashed because of the slash n. In child is also, because of this slash n, hello and hi is printed. B8 S1, don't compare about the scanf space there. Yeah, that is also some buffer related issue only. So whenever we supply the data from the keyboard, that will not directly come to our memory location. That will go to std in. Our scanf will fetch the data from std in. Whenever we print the data using the printf, printf will not directly put the data into the monitor. Printf will put the data into std out. So from std out, when from std out, when the data goes to the monitor, whenever there is a slash n, whenever there is a scanf after the printf, and whenever if you use a fflash, and whenever the process is terminated, in those cases it will. Observe, one more interesting thing I need to show you here. Don't put a slash in the second printf also. Observe, I'm not putting the slash in the second printf. Observe the output here. See, hello is not printed, hi is also not printed. All of you are observing? Here, hello is also not printed, hi is also not printed. Why? Because the data is present in std out only. Why? Because the data is present in std out only. It is not flushed into the monitor screen. Now, when we press Control C, is that hello and hi is going to print immediately? No. Why? Because Control C means abnormal termination. Control C means abnormal termination. All of you are getting the point? B8 M2, getting the point here. What happens is, once again try to observe. After compiling this program, when I load this program into the RAM, it becomes a process. This process is having the three buffers, in and std out and std error. So because of this printf, hello is present here. It is not flashed into monitor screen. And fork means a duplicate is created. Everything is duplicated. At the time of duplication, can I say parent std out is having hello, that hello is also duplicated to the child std out, B8 M2, getting the point? That hello is also executed, copied into the child std out at the time of duplicating. B8 M2, please respond it. After that, what happens is hi statement is there. Will you agree? These two statements, parent as well as the child, will execute. Will you agree? These two statements, parent as well as the child, will execute. Now hi is also here, hi is also here, and while one semicolon is there, so this two hello and hi is not flashed into the monitor. It will not go to the monitor. If you use slash n here, can you tell me? If you use slash n there, can I say this hello and hi are flashed into the monitor? Now I need to ask you one very simple question. Is this printf is executed by the child? Yes or no? Is the line number 4 printf is executed by the child? Yes or no? Answer is no. But how 2 times hello is printed? How 2 times the hello is printed? When the parent is created the child, at that time the buffer is duplicated. Because of that, the child is also getting the hello in a child std out. std in is not for printing the data. std in is for scanning the data. Means whenever you supply any data from the keyboard, that will go and sit into std in. std out is for printing the data. Now you tell me, instead of while one, I'll use a sleep of 10 seconds. Can I say parent as well as the child both are going to become sleep of 10 seconds? Parent as well as the child, both processes are in a sleep of 10 seconds. After 10 seconds, observe what happens to your program. After 10 seconds, my process will terminate. Then hello hi is printed immediately. After 10 seconds, observe hello hi is printed. Now tell me, now my process is terminated normally or abnormally? Tell me, now my process is terminated normally or because of any interrupt or any signal? No, normally it is terminated. So, what is a request? What is the procedure? Whenever you are writing the system programming using the C language, try to make an habit of putting, again, whenever you are using the writing the system programming using the C language, try to put /n for every printer. Otherwise, the program behavior will change. Now, anybody is having any doubt, you can ask it. You can raise your hand so that I'll enable your voice. If you want, you can speak it. So I hope you got the significance of /n. Whenever there is a /n is encountered, so the data which is there in the std out, it will go to the monitor. Whenever there is a /n is there, the data which is present in std out, it will go to the monitor. So when you are writing the C system programming using the C language, whenever you are writing the system programming using the C language, you need to put /n for every printer. So what is the difference between abnormal and normal termination? Abnormal termination means when you press Control C, when you segmentation fault came, floating point exception came, V1, getting the point. Abnormal termination means because of some interrupt, runtime error. Normal termination means everything is fine, normally terminated. More discussion will be once we started with the signals, we will need to discuss it. More discussion will be once we started with the interrupts, we need to discuss it. One student is asking DE8 S5, sir, but before we have did program in C, at that time we didn't get an output without /n, but now it is not happening. Why? I don't know. The student is S5. Try to experiment after the class. S5. Try to experiment after the class. Control C is abnormal termination. Control C is abnormal termination. Okay. S5, try to observe this. Try to check after the class this program. Print hello /n while 1. What is output? What is output? Can I say hello is printed? Hello is printed and my process is in a while 1 loop. Will you agree? Hello is printed, my process is in a while 1 loop. Okay. Now observe. I'll remove this /n. Can you tell me what is the output? Is the hello is going to be printed or not? Nothing. S5, got the point. Here any system programming concept? Here any system calls, am I using fork or anything? No, right? So before this type of situation you might have not encountered. Before in a C language you might have not encountered this type of situation. Is it clear? So the significance of /n, not only move the cursor to the next line, because of /n, the data which is present in std out buffer, it is going to be flushed into the monitor. Because of /n, the data which is present in std out, it is going to be flushed into the monitor. So In Linux system programming, better approaches Linux system programming, better approaches for every printf put a slash n so that parent std out is not going to be duplicated to the child std out at the time of duplication. So that is the reason. I don't know if you observed or not. Yesterday, whatever the programs I discussed, I used slash n only. I don't know. Yesterday, whatever the programs we used, will you agree? I used slash n only there. Yes or no? In yesterday's program, whatever the one fork, two fork, three fork, whatever we discussed, first printf I used slash n. If this significance is clear, type C in the chat box so that we'll move to the next. If this concept is clear, type C in the chat box so that we'll move to the next. Okay. Next discussion is again the fork related discussion only. Now you tell me int r is equals to fork if r double equals to 0 else. Who will execute the body of the if? Child. Who will execute the body of the else? Can I say parent? Now observe int r is equals to fork if r. Who will execute the body of the if and who will execute the body of the else? Can I say if is executed by the parent and else is executed by the child? If is executed by the parent and else is executed by the child? No. I'll create one more situation. Try to tell me. If fork double equals to 0, can you tell me the difference between the previous one and this one? In a previous two cases, the fork return value I stored into one variable. Then I am in a if condition I am checking. Again, in a previously, the fork return value I stored in the previously the fork return value I stored into R. We are checking the R. Now instead of storing the fork return value into separate variable, I am directly checking it. Now tell me, who will execute the body of the if? Who will execute the else part? Now can I say body of the if is executed by the child, else is executed by the parent? Else is executed by the parent. Will you agree? Next situation, try to tell me, if I write if fork, now tell me who will execute the if and who will execute the else? If I write simply if fork, who will execute the if and who will execute the else? Can I say if is executed by the parent, else is executed by the child? Else is executed by the child. Is it 4 different scenarios is clear? Again, let's check the first scenario, line number 1 to line number 10. Fork return value is stored into R, and in a if condition I am checking the R value. In a if condition we are checking the R value. So the body of the if is executed by the child, and the body of the else is executed by the parent there. And whereas in a second part, line number 12, the body of the if is executed by line number 12, the body of the if is executed by the parent, else is executed by the child. In line number 24 onwards, if you see line number 24 to 34, instead of storing the fork return value into separate variable, I am directly checking in a if only. If fork double equals to 0 means body of the if is executed by the child, else is executed by the parent. And whereas line number 36, if you see, the body of the if is executed by the parent, else is executed by the child. Is this is clear? Type C in the chat box so that we'll move to the next. Next discussion is we need to create the processes is like this. We need to create from one parent, we need to create 3 child processes. Again, from one parent, we need to create 3 child processes. From one parent process, we need to create 3 child processes. Void main. Now tell me, if fork double equals to 0, who will execute the if and who will execute the else? Can I say if is executed by the child 1, else is executed by the parent? If is executed by the child 1, else is executed by the parent. In a else, if I use if fork double equals to 0, now can you tell me here who will execute the if and who will execute the else? In a parent code, I written again if fork double equals to 0, can I say this is executed by the child 2, else is executed by the parent? Else is executed by the parent. In this else, if I use one more if fork double equals to 0, who will execute the if and who will execute the else? Can I say the body of the if is executed by the child 3 and body of the else is executed by the parent? Else is executed by the parent. I'll try to minimize this. I'll try to show you in a single things. So observe. So this is the child 1. This is the parent. This is the child 2. This is the parent. This is the child 3. This is the parent. So what is the task? From one process, we need to create 3 child processes. So all the 3 childs are having a common parent here. Will you agree? All the 3 child processes, in all these 3 child processes, If I print ppid, will you agree we will get the same? Again, in all these three child processes, if I print ppid, will you agree we'll get the same parent process id? Now you need to tell me, if I write one statement here, who will execute? If you write one statement here, this is the parent and these are the three childs, y plus 1, y plus 2 and y plus 3. Y plus 3. If I write one statement here, can I say parent and three childs will execute? C1, C2, C3. If I write one statement here, can you tell me who will execute this? Here. If I write one statement there, can you tell me who will execute that? Parent, child 2, child 3. Child 1 will not enter into this if else part, right? Child 1 will not enter into this else part. Will you agree? If I write one statement here in between this close brackets, who will execute? That means parent, child 2, child 3. Child 1 will not execute. Why? Because child 1 will execute only the if. It will not enter into the else. If this statement is clear, type C in the chat box, parent, child 2, child 3. Now, can anybody guess and can anybody tell me, if I write one statement here, who will execute this statement here? Parent and child 3. Parent and child 3. All of you are getting the point? So can I say this is the common code for parent and all the three childs? This is the common code for parent and child 2, child 3. This is a common code for parent and child 3. This is the exclusive code for child 1. This is the exclusive code for child 2. This is the exclusive code for child 3. Is that point is clear? Is this situation is clear? Type C in the chat box. Okay. Now what I will do is, how can I check all these three childs are having the common parent or not? How can I know all these three childs are having a common parent or not? So what we can do is, we can print ppid printf in child 1, pid is equals to percentile d, ppid is equals to percentile d slash n get pid and get ppid. Similarly, yy p, can I say in child 2 this is, and here in child 3 this is. This is in child 3. And let's put while 1 at the end. Can I say this is a common code? Common code for all the processes, parent as well as three childs. So header file we need to include header.h. See, all the three child processes are having the common parent. Will you agree? All the three child processes are having a common parent here. So any doubt in this? Any doubt in this? Who is executing the body of the if? Who is entering into the body of the else? Again in the else, once again one more if else like this. Now suppose I want to create one scenario. Suppose from one process I need to create a child. From that child I need to create one more child. From that child I need to create one more child. Till now we created like this from the parent three childs. So this is a program for this. But now the requirement is parent process need to create a child 1 need to create a child 2, child 2 need to create a child 3. Now can you tell me who is a parent for child 3? Who should be the parent for child 3? Child 2. Who should be the parent for child 2? Child 1. Who is a parent for child 1? Can I say P? This is a scenario we need to. Sir, here how else part is executed? S7, who will execute the body of the if here? S7, who will execute the body of the if? Parent or the child? Child. Who will execute the else? Who will execute the else? Parent. That's what. In a parent is calling the fork again. Parent is calling the fork again. Getting the point? Now this is executed by the child too, because fork returns 0 in a child, and else is executed by the parent. Now got the point? S7. Okay. Now what is the scenario? What is the scenario? Means both conditions are executed. Yes. If condition is checked by the parent as well as the child. Again, the if condition is checked by the parent as well as the child. But parent, in a parent condition becomes false. In a child condition becomes true. Now can you tell me the same situation you can create like this also? If a fork, who will enter into this if? Who will enter into this if? Parent. Else, child. Again I will write if fork. Who will enter into this if? Parent. Else, child. Like this also you can create the scenario. This type of scenario. Here one more fork you need to put. Getting the point? All of you are getting the point? Okay. Now the situation is process Y need to create Y plus 1. Y plus 1 need to create Y plus 2. Y plus 2 need to create Y plus 3. Will you agree? The situation is like this. Process Y need to create Y plus 1. Y plus 1 need to create Y plus 2. And Y plus 2 need to create Y plus 3. Again, process Y need to create Y plus 1. Y plus 1 need to create Y plus 2. And Y plus 2 need to create Y plus 3. Will you agree? Process Y need to create Y plus 1. Y plus 1 need to create Y plus 2. Y plus 2 need to create Y plus 3. So now observe, I'll write hash include header dot h void main. Now tell me, if fork double equals to 0, who will enter into the if, who will enter into the else? According to y and y plus 1, you tell me, who will enter into the if part? Can I say y plus 1? Hmm? Who will enter into the else? Can I say y? Will you agree? Y. Hmm? Now you tell me y plus 1 need to create y plus 2. I will agree. Y plus 1 need to create y plus 2. So here I need to write if fork double equals to 0. In a child I need to write. Now can you tell me here this if is belong, who will enter into this if, who will enter into this else part? Who will enter into this if? Can I say y plus 2? Y plus 2 will enter into this if, else y plus 1. In this if, once again I need to use one more if fork double equals to 0, who will enter into this and who will enter into this else? Can I say here y plus 3 and here y plus 2? Are you forgetting the point? Y plus 3 and y plus 2. According to that, you can decide which is a common code, which is an exclusive y code, which is a y plus 1 code, y plus 2 code, y plus 3 code. With this, you can decide. Now here, now try to understand here. I will try to create, show you the scenario here. Tell me, this is the exclusive y code. This is the y child code B9S7. Getting the point? Who will enter into this if? Who will enter into this if? Can I say child? Who will enter into this else? Can I say y parent? Now in this, again this child is calling the fork. Again child, one more child is created and parent. Now can you tell me y plus 1 is a child of what? Can you tell me y plus 1 is a child of y plus 1 is a child of y plus 2 is a child of y plus 1, y plus 3 is a child of y plus 2. I hope all of you are getting this point. So this is how you can create the type of scenarios. Is that is clear? Is this situation is clear? Type C in the chat box. Now, can I say here no two processes are having the common parent? Will you agree? In this scenario, there is no two processes are having the common parent. Okay. Let's understand one more important scenario. Now, I need to ask you with respect to system function. Header.h void main system ls system pwd. Now tell me, these two commands are executed concurrently or sequentially? Can you tell me these two commands are executed concurrently or sequentially? Can I say these two commands are executed sequentially? Will you agree? These two commands are executed sequentially. Now observe, I'll comment this portion. If fork double equals to 0, else. Now here if I use system ls, here if I use system pwd, now you need to visualize these two commands are executed concurrently or sequentially. Now you need to visualize these two commands are executed concurrently or sequentially. Answer is concurrently. Concurrently means one command execution is not depends upon another command execution. Now here what happens? Try to understand. Here what happens? Try to understand. After compiling this program, when I load this program into the RAM, can I say it becomes one process? After compiling this program, when I load this program into the RAM, can I say it becomes one process? Who is a parent for this process? Can you tell me? Who is a parent for this process? Can I say bash is a parent for this process? Now this process is calling the fork. Can I say a duplicate process is created, y plus 1? Now one thing you need to observe, process manager will give a separate time slice to the y, as well as the process manager will give the separate time slice to the y plus 1. One thing you need to observe here, process manager will give a separate time slice to the y process, and process manager will give the separate time slice to the y plus 1. Now will you agree, in y plus 1 I am calling the system here, system pwd. In a y I am calling the system, in y plus 1 I am calling the system ls. Again, in an exclusive parent code, I am calling the PWD, system PWD. In an exclusive child code, I am calling the system ls. In exclusive parent code, I am calling the system PWD. In exclusive child code, I am calling the system ls. Will you agree? Now tell me, in a child process, system ls, can I say sh and ls command is executed? Because of the system pwd, can I say sh and pwd is executed? All of you are getting the point? So here this command and this command execution is not dependent. Both will execute concurrently. In a child, I am using a system ls. In a parent, I am using the system pwd. So Those two commands are executed concurrently. One command execution is not depends on another command execution here. How many processes involvement he is here? Can you tell me? How many processes involvement here? Here, how many processes? Not two. 1, 2, 3, 4, 5, 6 processes involvement. Including the bash, it is a 7th. Including the bash, it is a 7th. So one good point is saying by one student, in one process, if you are calling the 2 times system function, then those two commands are executed sequentially, correct? In two different processes, when you call the system function, so those two commands are executed concurrently. N1 is asking, sir, even though concurrent, we cannot predict is ls or pwd will execute first. I am correct? Answer is yes. But can you tell me, BE8N1, can you tell me, in my laptop, who is getting the CPU time first? Parent. So, can I say, normally we can guess first PWD, after that ls? Huh? Now you tell me, now here, instead of ls, ./p1 is there, which is an infinite loop. Is PWD executes or not? Try to understand line number 5 and line number 6. Instead of ls, suppose ./p1, which is our own created executable file, which is an infinite loop. Is PWD executes or not? No. But here, ./p1, is PWD executes? Here, in this case, ./p1 is there. Here, PWD executes. Answer is yes, it will execute. Now, in this way, can I say both are executing concurrently? One process execution depends on not, one process execution is not depend on another process execution. One process execution is not depend on another process execution. So this is how we can say that, this is how we can say that one process, these two commands are executing, these two commands are executing child will execute ls command. In a child process, you are calling the system. S7, child will not execute ls. Child is calling the system. Parent is calling the system and PWD there. Child is not executing the ls, child is calling the system. Is that is clear? Child will execute ls and parent will execute PWD. That's what I'm not. That's what S7. I hope you got. Child is not directly executing the ls. In a child, we are using system ls. So in a child, sh is created. Under the sh, ls is executed. Under the sh, ls is executed. Is that is clear? Now for this sh, one thing I need to tell you, There is no separate, there is no rule that shell should execute under the terminal only. Without terminal also shell will execute in this like. Who is a parent for this sh? Who is a parent for this sh? Y plus 1. Who is a parent for this sh? Y. Who is a parent for this ls? Who is a parent for this ls? This sh. All these are running in one terminal only. All these are running in one terminal only. All these are running in one terminal only. Is it clear? So this is how, if you want to execute concurrently, so you need to create multiple child processes. In each child, one command you need to execute. Again, if you want to execute the commands concurrently, you need to create multiple childs. In each child, you need to execute the commands. In each child, you need to execute the commands. Got the point? BE8 E2 is asking, sir, here we are using if and else. So at that time, only either if will execute or else part will execute. How concurrently? BE8 E2. I don't know yesterday you are present or not. Today you are focusing the class or not. Who will execute the body of the if here? Can I say child process? Who will execute the body of the else here? Can I say parent process? Yesterday I told you, when we use fork system call, we can execute if part and else part, but not one process, two processes. E2, got the point? As a C programmer point of view, when if body of the if is executed, else will not execute, or else is executed, body of the if will not execute. But as a system programmer point of view, from last session and today also we discussed, we can make if as well as else to execute, but not by one process, by two different processes. Now can you tell me who will enter into the body of the if here? Which process will enter into the body of the if here? Which process will enter into the body of the if here? Can I say child? Which process will enter into the body of the else here? Can I say parent? I hope everyone understood this. So next discussion will be on the concept called orphan process and zombie process. Is it clear? In the next session, in a tomorrow's session, we are going to talk about what is an orphan process, what is a zombie process, what is an advantage, what is a disadvantage, how to avoid the orphan process and zombie processes. Everything we need to discuss it. Is it clear? Is it clear? So we'll wind up the today's session. Thank you very much. I'll upload these programs and this PDF also I'll upload it. Anyway, tomorrow we are going to discuss this. This PDF also I'll upload it. Okay. Thank you very much.